In this video, our primary aim is to keep it simple and easy. We are asked what is the magnitude and the direction of the vector shown below. We're looking at the resolution of vectors. First of all, the first thing to do is to number the vectors or the forces. We have F1, we have F2, we have F3, and we have F4. So now we have 4 forces. We need to know that each of these forces has the X component, which is the horizontal component, and the Y component, which is the vertical component. The formula to find for the X component, which is Fx, is F cos theta. The formula to find for the Y component, which is Fy, is F sine theta. And the formula to find the direction, which is theta, theta is simply the tan inverse of f of y over the f of x. So these formulas are very important for us to solve this problem. And in case you don't know how to derive this formula, we have a video on derivation of these formulas of resolution of vectors. Now, first thing to do is we have listed out the forces. Let's draw a table. Why I prefer drawing a table is that it will make the work appear on a chart and make it more neat. So let's draw a table. We have this table. All right, we have the force. After the force, use another pen. We have the X component. Then we have the Y component. Then we have the theta, or the angle of inclination. And let's start with the first one. The first one is F1. F1, the first force there is 10 Newton. Now, what is happening to 10 Newton? 10 Newton is inclined towards the horizontal, towards the x-axis. If you recall that the coordinate system has 4 quadrants. 1, 2, 3, 4. This is 0 degree. This is 90 degree. This is 180 degree. This is 270 degree. And this is also 360 degree. Now, this stuff, the first force is inclined at the horizontal x at about 0 degree. Now, the first inclination, angle of inclination is 0 degree. So what I'll be having is that my F1, because I'm going to look for F1x and F1y. F1x for the horizontal, F1y for the vertical. All right? So I have F1x, which is equals to F cos theta. Now F1y, which is equals to F sine theta. Now for the F1x will become 10 cos 0 degree. All right? For the F1y, it will become 10 sine 0 degree. Now, if you have understand that, we complete the table. All right? So we go to the F2. F2 force is 15 Newton. So we have there 15 Newton. Now, understand also that this has an angle of inclination towards at about 45 degree. All right, at 45 degree, it's also moving towards the x-axis. It has Fx and it has Fy. It has both the X component and the Y component. Now, let's resolve the second force. It will become F2x, which is the X component of the second force, is, this is F1, please. This is F1, please. So this is become F2 cos theta. All right? And then for the Y component, F2y will become F2 sine theta. Now, don't forget that the angle here is 0 degree, while the angle of inclination here is 45 degree. Now, having said that, what is my F2? It's going to be 15 cos 45 degree. What's my F2? Again, 15 sine 45 degree. Now we're moving to the next one. The next one is the third force, F3. F3 is equals to 20 Newton. So we have 20 Newton. Now for the 20 Newton, what is happening here is that if I'm moving, this is my reference angle. 40 degree is my reference angle. But I want an angle relative to the positive x-axis. So what I'm going to be doing is that, let me use another pen to illustrate to you. I want an angle that is relative to the positive x-axis. Related to the positive x-axis, starting off from the positive x-axis. So what I'm going to do with the angle is that this is the first quadrant. The theta in the first quadrant is equals to the reference angle. But in the second quadrant, the angle relative to the positive x-axis is gotten by saying 180 minus theta. All right? So what is here is 40 degrees. What I'm going to do is 180 minus 40. What I'm going to be having is 140 degrees. So the angle, the reference angle is 40. There are some persons that we want to say minus 40 degrees because it's towards the negative x-axis. This is negative x-axis. This is positive x-axis. But you can actually save yourself the time by saying the relative angle from the positive x-axis to this point is 180 minus 40, you get your 40. In fact, we'll have a video on angle of inclination and reference angle and stuff like that. So we're going to be using 140 degree, and you can use minus 40 degree if you want to. So we have the F3 will be F3x is equals to F3 cos theta. F3y is equals to F3 sine theta. Now, my F3 is 20 Newton, so it's 20 cos theta. This is 20 sine theta. Okay, now my theta there is 140, so let's not waste our time. My theta there is 140. So we'll move to the next one. The next one is the fourth force, F4. Now F4, or the fourth force, is 25 newtons. Let's write that down. 25 Newton. Now for 25 Newton, recall that it's going to be F4x, which is equals to F4 cos theta. The next one is F4y, which is equals to F4 sine theta. Now, let's find the angle of inclination. Now, for the angle of inclination, it's at the third quadrant. And I'm still looking for the angle that is relative to the positive x-axis. If I'm looking for the angle that is relative to the positive x-axis, what do you think I'm going to do? What I'm going to do is to say 180 plus theta. I'm going to get the angle here. Now, I'm going to be having 180 plus 30 degrees. 180 plus 30 degrees. This is 210. It's going to give me 210. All right? So what I'm going to be doing now is that just let's manage the board. We're going to be putting now F25 cos 210. And then 25, which is still my 4th Newton, sine 210 degree. Now let's get our answer. All right, I'm going to put my answer here. The summation of x forces and then the summation of y forces. All right, let's do that now. You can actually go ahead and plug this into your calculator. You can go ahead to be getting the answer if you want to, but because of time, let's just do it. 10 cos 0 plus 15 cos 45 plus 20 cos 140, okay, plus 25 cos 210, okay, 210. I'm having everything is equals to 16.364. So let me approximate the 16.365. So I'm having not just 16, negative 16, negative 16.365 as my the sum of the x-axis, sum of the x components, sorry. So I have the next one. Let's go to the next one. 10 sine, okay, 10 sine 0 plus 15 sine 45. Make sure that your calculator is in degree mode. You can actually be getting the answer and then after everything you add it up, but there's no time for that now. You can confirm it with your calculator there at home. Now 45 degree plus I'm having the next one. The next one is 20 sine 140 degree. All right. So I have plus 25 sine 210 degree. All right. What I'm having is 10.962. So I have here to be 10.962 Newton. All right, Newton. Now I'm going to redraw my angle. Let me look for a pen. Clean up some of this side. Now the angle is like this. I mean the vector is now just one vector, the x-axis and the y-axis. Notice that the x-axis is towards the negative x-axis. So this is the negative x-axis. So the vector is moving towards the direction at about minus 16.365. And then it's moving towards the positive x-axis, positive y-axis because it's positive. Positive is upward, negative is downward. This is positive y, positive x, negative x. Now, this is negative x, so we're moving to this direction. Now, it's moving to the positive y. So what are we doing? We're going up at about 10, let me make a space, 10.962. Now, we're going to look for the hypotenuse and look for the theta, the direction. So we're looking for the hypotenuse and we look for the theta, which is direction. Let's write it over there. If you recall that c squared is equals to the squares of, if you recall that c squared is equals to a squared plus b squared. This is Pythagoras theorem, or the Pythagoras theorem we got from trigonometry. All right, so that we'll be having c is equals to the squares of a squared plus b squared. So what do I have? So that my c, my resultant vector, because this is my c, my resultant vector is all these guys. Now we have the negative 16.365 all square plus my y 10.962 all square. Now let's put that into our calculator and see what we're going to be having. All right. Now we have the squares of negative. We have the squares of. If you want to, you can remove the negative sign. You will still get the same answer. Minus times minus is plus. Because of this bracket, minus times minus is plus. If you want to, you can remove it. If you want to, you can add it. So I have 16.365 raised to the power of 2 plus 10.962 raised to the power of 2. So I'm having 19.697. 19, my answer, my resultant vector force is 19.697 Newton. So that's what I have. So if you want me to get my theta, my angle of inclination, I think I should be cleaning up some of these. Let's clean up some of these so that we can make space for ourselves. Now, for me to get my angle of inclination, I need to know that theta is equals to the tan inverse of f of y over f of x. Now, which tan inverse of f of y? Where is my f of y? F of y is 10.962 divided by f of x is 16. Forget about the negative sign now. 16.365. Now close the bracket. All right, let's do that now. So I shift tan, 10.962 divide by 10, oh sorry, not 10 now, divide by 16.365. All right, so what is my answer? Let me review it again. Shift tan of 10.962 0.962 divide by 16, all right, 16.365. All right, I've got my answer now. This is 33.84 degree. So my theta here is 33.80, 33.81, approximately to 33.8, that's okay, degree. All right, so this is 33.8 degree. Now notice that it falls on the second quadrant. What I'm going to do, because it's on the second quadrant, is actually 180 minus my reference angle here, which is 33.8, and I'm going to get the angle I'm looking for that is directed towards the positive x-axis. So what we're going to be doing now is 180 minus 33.8. I'm having 162.2. So I'm going to be having over here 146.2 degree. And my resultant vector here, is equals to that over there. Now, this is my resultant vector. Let me write everything down now. Is equals to 19.697 Newton. And then the theta is 146.2 degree. Now, this is the magnitude and this is the direction of the vector. This is all we've got for you in this video. If you have a question, drop it on the comment section. We believe this video could have helped you at all. Give it a thumbs up and share with other students to learn. And you are always also welcome to follow for more.